In this video, we're gonna talk about expressing sums as products. And we're gonna use our well-tried and used and verified strategy as U substitution and V substitution. So what we're gonna do, we're gonna let alpha be equal U plus V divided by 2. And we're gonna let beta be U minus V over 2. So if we make that substitution, let's see what alpha plus beta is going to be. Alpha plus beta is going to be U plus V over 2 plus U minus V over 2. What do we have? Well, when we combine these fractions, we're going to have U plus V plus the numerator of the second fraction, U minus V over 2. Well, V and V cancels out. What do we have? We have 2U divided by 2, so that's just U. Okay, so what happens when we subtract alpha minus beta? So that will be U plus V over 2 minus U minus V over 2. So when we, again, combine these two fractions, we have the same denominator. In the numerator, we have U plus V minus. Remember that this negative will be distributed, so U will change its sign, and so will the sign of V. So now the U's will cancel out, and we're going to have 2V over 2, so that equals to just V. Okay, so now when we have, so that's our preliminary work, okay? So that's the reasoning that will go into our derivation of our new formulas. Okay, so now we're going to look at sine alpha, sine beta. And according to our formulas, that's 1/2 of sine of alpha plus beta plus sine of alpha minus beta. All right. Now, what we're going to do, first of all, we're going to multiply both sides by 2 to eliminate this 1/2, right? So we're going to times 2 times 2. So we're going to have 2 sine alpha sine beta equals sine of alpha minus beta plus sine of alpha plus beta. And now what we're going to do, we're going to make our substitution. Instead of alpha, we're going to put U plus V over 2, and instead of beta, U minus V over 2. So what do we have? We have 2 sine of U plus V over 2 times sine of U minus V over 2 equals sine alpha minus beta. Alpha minus beta is just V. And sine of alpha plus beta, well, alpha plus beta is just U. So we have a formula that turns a sum of two angles into the sum of the sines of two angles into a product of sines of those two angles. All right, so, and we can actually continue this reasoning and come up with all the rest of the formulas. And this is This is the collection of those formulas. So we have the formula for sine alpha plus sine beta, sine alpha minus sine beta, and the cosines. Okay, so we're going to use these formulas. And our first example using the formulas is the sine of 4 theta minus sine 2 theta. So it's straightforward applying the formulas. So I'm gonna go ahead and write it out. So it's 2 sine of alpha minus beta divided by 2. So 4 theta minus 2 theta divided by 2 multiplied by the cosine of alpha plus beta. So 4 theta plus 2 theta divided by 2. All right, so that's 2 sine of, 2 theta divided by 2, just theta, cosine of 6 theta divided by 2, 3 theta. That's it. Pretty straightforward. And I want you to try this problem again. Go ahead and try it, just applying the formula straightforward, but it will help you to start getting those formulas into your memory bank. So go ahead and pause here and try this, work out this problem. And we're gonna proceed to our last example in this video, example 5, which says evaluate cosine 15 degrees minus cosine 75 degrees. Checks the answer with a graphing calculator. Okay, let's take a look. So cosine minus cosine formula will tell us, okay, let's copy. So the formula tells us it's a negative 2 sine of the average of those two angles, sorry. Multiplied by the sine of the difference. Half of the difference. Okay, so let's simplify. Negative 2 sine of 90 divided by 2, that's 45, times sine of, 15 minus 75 is going to be negative 60 divided by 2, negative 30. And now we should just plug in the values from our unit circle. I'm gonna, these values are gonna be fractions, right? For 45, we have square root of 2 over 2. For 30, that's 1/2. Sine of 30 is 1/2, but because it's sine of negative 30 is gonna be negative 1/2. And I do have this factor of negative 2 here, which I'm going to turn into a fraction as well. So instead of 2, I'm going to write negative 2 over 1. Instead of negative 2, I'm going to write negative 2 over 1. So now I'm going to multiply these fractions. Again, I have a negative times a negative, which makes it positive, times a positive. Okay, so the total product is positive. So I'm going to have negative 2 square root and negative 1. That's going to be 2 square roots of 2 on top. On the bottom, it's 1 times 2 times 2. So that's going to be 4. And after we simplify this expression by a factor of 2, we're going to get square root of 2 over 2. So that's our example 5. That's the end of this video. I'll see you in the next one. In the next one, we're gonna actually use those formulas to prove identities.